now we want to talk about scalars and vectors. So do you remember back in lesson number 3 when I kept saying that speed was the same thing as velocity? Well, that's not true, okay? And I said that later we would talk about the difference between what speed and velocity are. Now's the time to do it. So it turns out that speed is a thing called a scalar, and velocity is a thing called a vector. So a scalar only has a number associated with it. So like for example, the speedometer on your car might be in miles per hour, or it might be in kilometers per hour. Okay? So if you look on the speedometer of your car, you're going to find that it tells you how fast that you're going, but it doesn't tell you what direction that you're going in. It's just giving you a number. Now, on the other hand, if you know how fast you're going and you have a compass and you would say that you're going at 55 miles per hour and you're going north, then you have just given a vector and you have told your velocity. So speed is how fast you're going, it's just a number, but velocity, you're telling how fast you're going and in what direction that you're going. So some other examples of scalars would be time. So you don't say it's 3 o'clock to the west. So you would say it's 3 o'clock. Mass. So mass is in kilograms. It's just a number. It doesn't have a direction associated with it. Energy. So energy is in joules. So it's not, you don't say that it has 100 joules of energy at a 30-degree angle. Okay? Electric charge was another example of a scalar. And then temperature. So the temperature, it's just a number. Now let's compare these to different kinds of vectors. So position, so that the distance that you travel depends on what direction you're going in. So you could go this far at a 45-degree angle, or you could go this far. Notice that I'm representing it with an arrow. The length of the arrow tells you how big the quantity is. So this would be a large distance, and then this would be a small distance. And so these are going to be vectors because it's a distance in a certain direction. Then we had velocity, which is how fast is the distance changing. So if velocity v is equal to r divided by t, okay, now this would be a vector, the distance, because you say how far is it, and then also what direction. T, though, is a scalar, but when you take a vector divided by a scalar, you end up with another vector. So your velocity is a vector. Your acceleration is a vector, because acceleration is your change in your velocity over time. So velocity is a vector, this is a scalar, and when you divide them, you end up with a vector. Force is going to be a vector, because we just got through saying that force is equal to ma. Okay, and a, now this is the way that you can represent it, is put a bar over the top of it. So a, we just got finished down here, we said that a is a vector, so therefore force is a vector. So again, we could put a bar over the r, over the v, and then over the A. So that's how we would indicate that those are vectors. And then in a previous episode, we talked about electricity and magnetism. And do you remember that we talked about the electric field? So the electric field was given by this symbol here. And then we said that, let's say it was a positive charge Q, then it had the electric field that was kind of like a pin cushion. And so it was a whole bunch of arrows that emanated from that charged particle. And so this, we said, was the electric field created by that positive charge. So the electric field has a direction associated with it, and it has a magnitude associated with it. And then we also said that, for example, a wire that is carrying a positive current in that direction would have a magnetic field that would wrap around it. So if you don't remember any of this, then go back to some of those previous episodes. And so we said that the magnetic field would wrap around that current carrying wire, and then that was called B. And so you notice it's got an arrow, so it's a vector. And then later we're going to talk about gravity, and gravity also is going to be a vector. All right, so now that we know that force is a vector, how do we add vectors together? So we'll see that in our next segment.